Hey, 7th grade. This week we're going to focus on a new type of equation, absolute value equations, and learn how to solve those. Before we get into the actual equations, though, I want to review what we mean by the term absolute value. So the definition of absolute value is this. It is a number's distance from zero on a number line. Okay, that is what we mean by absolute value. It's how far a number is away from zero on a number line. And the symbol we use for absolute value is just these two vertical bars. Okay, so if you see something like this, a 5 and then two just vertical bars around it, we call that the absolute value of 5. So in these 6 examples down here, for example 1 here, I just want us to identify what the absolute value is of each of these numbers inside the absolute value bars. So for A, we have the absolute value of -2. Well, if you think about a number line, okay, here's, we'll put 0 in the middle. Okay, -1 would be right here, -2 would be right here. -2 is 1, 2 whole spaces away from 0 on the number line. Okay, so because it's 2 spaces away, we say that the absolute value of -2 is just 2. +2 would be over here. It is also 2 spaces away from 0 on the number line. It's just 2 in the other direction, but it's still 2 spaces away. So the absolute value of +2 is also 2. Okay? -2/3, its absolute value would be 2/3 because it is 2/3 away from 0 on the number line. So is +2/3. Okay? It is also 2/3 away from 0 on a number line. -1.5, its absolute value is 1.5 because it's 1.5 spaces away from 0, as is +1.5. Okay, so you may notice something about all the answers here in example 1. Okay, all of the answers are positive. And that's because when we're measuring distance on a number line, okay, we always measure distance using a positive. We don't say this one is negative spaces away from 0. We just say how many spaces is it. So even though the definition of absolute value is a number's distance from 0 on a number line, anytime you're taking the absolute value of a single number, you're going to get a positive answer. Okay, you're going to get a positive answer. If it's already positive, the number will stay positive. If it's a negative, when you take the absolute value of that number, you get a positive. So that's what you want to remember about absolute value. Let's try a few more, a little bit more complex expressions here. So we're going to simplify each of these expressions. We're going to treat absolute value bars for this kind of like we do parentheses. So if we see anything inside the absolute values that we can simplify, we're going to do that first. So for instance, A here, we have the absolute value of 3 minus 8. So I'm going to do what's inside the bars first. We know that 3 minus 8 is -5. So this is really asking us to find the absolute value of -5. Well, the absolute value of -5 would just be 5. Okay, for B, we have the absolute value of 3 minus the absolute value of 8. Okay, so this time, the 3 and the 8 are their own separate absolute values, so we're going to go ahead and simplify each of these first. The absolute value of 3 is just 3. The absolute value of 8 is just 8. So this is really asking us to take 3, subtract 8. Well, the number 3 subtract the number 8 is -5. So in this case, even though the problem has absolute values in it, you're getting a negative answer because you're taking the absolute value of one number, subtract the absolute value of another one, 3 minus 8. For C here, we're going to do what's on the inside of the absolute value first. So it's asking us what is the absolute value of 4 times 5. 4 times 5 is 20. The absolute value of 20 is just 20. For D, this time it's asking us what is the absolute value of -4 times the absolute value of 5. So those absolute values are separate. We're going to simplify each of the absolute values first. The absolute value of -4 is 4, and the absolute value of 5 is 5. So this is asking us really what is 4 times 5? Well, that is 20. For E here, we have the absolute value of 12 divided by -3. We'll do what's inside that absolute value first. 12 divided by -3 is -4. The absolute value of -4 is simply 4. And then finally for F, notice how this one's a little bit different than E. This one's asking us what is the absolute value of 12 divided by the absolute value of -3. So this time those absolute values are split up. The absolute value of 12 up on the top is just 12. The absolute value of -3 on the bottom is just 3. And so this one's asking us basically what is 12 divided by 3? Well, that's going to give us also 4. Okay, moving on to the next set of examples. These are asking us a little bit different of a question, okay? It's asking us to determine the number of solutions to each equation. I'm not asking for what the answers are, I'm just asking for how many solutions that each of these have. And this is a little bit different than what we've done in the past. So I want you to take a look at A here and let me explain what this means. I'm giving you a very, very basic equation. X equals 5. In fact, there's really nothing you can do to that equation because it's already solved. I'm telling you that x equals 5. So my question is, how many solutions are there to this equation? Basically, how many answers are you getting for x? Well, if x is equal to 5, that means x is only equal to one number, and so there is one solution to this equation. That solution is 5 itself. Okay, so that's what I'm asking for each of these problems. How many answers do you get for x? In this case, we get one answer, x equals 5. If you look at part B here, you're not going to get just one answer. Okay, there are some equations that you get more than one answer for. So for B here, this is saying the absolute value of x equals 5. Well, think back to what absolute value means. Okay, what numbers on the number line are 5 away from 0? Okay, that's what this question's asking. What number can you plug in for x so that you get an absolute value of 5? What numbers are 5 away from 0? Well, we know that the absolute value of positive 5 is equal to 5. So that would be one solution right there. X could be equal to positive 5. The other possibility is x equals -5 because the absolute value of -5 is also just equal to 5. So if I plugged both of these in for x and I checked, both of them would check out. So really, this equation here has two solutions, positive 5 and -5. There are two solutions for this equation. For C here, this one is saying the absolute value of x is equal to -5. What numbers are -5 away from 0 on the number line is what this is asking. Well, there is no number that is -5 away from 0. If you take the absolute value of a number, you're not going to get a negative. So for this one right here, there would be no solutions to this. This would be an example of a no solution problem. You can't take the absolute value of a single number and get a negative. Finally, D is asking, okay, the absolute value of what is equal to 0. Well, there is only one number that is 0 spaces away from 0 on the number line. That would be 0 itself. Okay, the absolute value of 0 is the only thing that is equal to 0. So this would be another example of one solution to the equation. Okay, one solution. That solution is x equals 0. Okay, the reason I wanted to talk about this here in A through D is because it's going to help us as we're starting to solve absolute value equations here in the next part of the video. Okay, so I want you to notice something about these answers we just did here in example 3. Okay, A, B, C, and D. Notice that if the absolute value is equal to a positive number, okay, you have the absolute value and it's equal to a positive number. That would be like B right here, example B. Then there are two possible solutions to your equation. Okay, if the absolute value is equal to a positive number, there are two possible solutions. We got 5 and -5 for our solutions. If the absolute value is equal to a negative number, okay, if you have the absolute value equal to a negative number, that would be the example C right here, then there is no possible solution. Okay, you can't have an absolute value expression be equal to a negative number, so there is no possible solution in that case. And then finally, if the absolute value is equal to 0, that'd be this last example over here, D, absolute value of x equals 0, then there is only one possible solution to that equation right there. Okay, so here's the point of all this that I wanted to make. An absolute value equation, okay, first of all, has a variable within the absolute value sign. That's the definition of an absolute value equation. Okay, there's going to be a variable inside the absolute value bars. Okay, that's what we're going to be talking about here in these next sets of examples, what we're going to be doing this lesson here. And absolute value equations can have either two solutions, one solution, or 0 solutions. They can have 2 answers, 1 answer, or they can be a no solution. The first step to solving an absolute value equation is always going to be to isolate the absolute value bars. Okay, isolate the absolute value expression, and so that's what we're going to practice in the last half of this video with examples 4 through 7. So this is how we solve absolute value equations. For number 4, we have the absolute value of 2x minus 1 is equal to 5. Okay, so for this equation right here, I know two things. Okay, I know that this expression inside my absolute value bars, this 2x minus 1, okay, it can be equal to one of two things. It can be equal to positive 5, because positive 5 is 5 away from 0 on the number line, or that expression 2x minus 1 could also be equal to negative 5, because negative 5 is also 5 away from 0 on the number line. Okay, so that whatever's inside these absolute value bars here, okay, whatever is going in for this blue box, which is 2x minus 1, it could be either positive 5 or negative 5. So every time we're solving an absolute value equation, we're going to set up two equations and solve them. We're going to set up an equation basically without the absolute value bars. So what I did here is I just took this equation and I took off the absolute value bars. And then I wrote a second equation, but instead of positive 5 over here, I did a negative 5. I made this sign the opposite. So what I'm going to do now is I'm going to solve both of these equations separately. I'm going to start with the one on the left. I'm going to solve it by adding 1 to both sides. So I get 2x equals 6, and then I'm going to divide both sides by 2, and that gives me x equals 3. So I know that 3 is one of my solutions to this equation, but there's a second possibility as well. If I add 1 to both sides on this second equation I have, 2x equals negative 5 plus 1 is negative 4, and then I divide both sides by 2, I get x equals negative 2, which is also a possibility. Okay, so there are two possibilities for this equation here. You can have positive 3 as one of the answers, or you could also have negative 2 as the other answer. Anytime we have more than one solution to an equation, we write them just like this. Okay, one separated and then the other separated by a comma, and then we put those solutions in what we call braces. Those are just those squiggly lines that look like this. Okay, anytime an equation has 2 or more answers, we're going to put them in braces, just like this. Okay, number 5 here, we're going to do the same thing as we did for number 4. We have the absolute value of 3x plus 2 equals 4. So I'm going to take what's inside the absolute value. That would be this part right here, 3x plus 2. And I know that 3x plus 2 can be equal to one of two numbers. Okay, it can be equal to one of two things. So I'm going to write two separate equations here. 3x plus 2 could be equal to positive 4. Because positive 4, if you take the absolute value of it, you get 4. 3x plus 2 could also be equal to negative 4, because if you take the absolute value of negative 4, you also get 4. So again, when you're solving absolute value equations, you always have to set up two separate equations to solve those. Now, what I want you to do is pause the video, and I want you to solve both of these equations separately, just like I did for number 4, and see what you get for your answers. Once you get those, please click play to check. Okay, if you solve both of these equations correctly, for the first equation, you should have gotten x equals positive 2/3. Okay, you can take a look at my work right here, positive 2/3. The second equation, you should have had x equals negative 2. So both of these are possibilities, okay, for your equation up here. They're both solutions. If you plug both of these back in and check, they'll both work out. So 2/3 and negative 2 are your two answers. Okay, finally we have two more examples. These are going to be just a little bit longer than the first two. Notice in both of these equations, number 6 and number 7, we have a little bit extra on the left side. We don't just have the absolute value bars by itself. We have an absolute value of x plus 2 times 3 and then subtract 1 on number 6 here. So the first thing we need to do with absolute value equations that look like this is we need to isolate just the absolute value part. So what I'm going to do is I'm going to focus on getting this entire expression here, the absolute value part, by itself before I write two separate equations. So I'm not going to start out by writing two separate equations yet. What I'm going to do is I'm going to isolate this absolute value part right here. I'm going to do that with two steps. The first step is I'm going to get rid of this subtract 1 by adding 1 on both sides. Okay, so when I add 1 on both sides, that's going to leave me with just 3 times the absolute value of x plus 2 equals 8 plus 1 is 9. The second thing I'm going to do is get rid of this 3. So anything not inside the absolute value bars you want to get rid of. Okay, so I'm going to divide both sides by 3 since it was multiplying. That's going to leave me with the absolute value of x plus 2 equals positive 3. Now we have an equation that looks like what we started with on 4 and 5. And so now once I get to this step right here, okay, we're isolating the absolute value first. Once I get to that step right there, now I'm going to write my two separate equations. So now I'm going to take what's inside this absolute value part, okay, this x plus 2. I'm going to drop my absolute value bars now, and now I'm going to write my two separate equations. Those equations would be x plus 2 equals positive 3, or x plus 2 is equal to negative 3. So when I solve both of these equations separately, I'm going to subtract 2 here. That gives me x equals 3 minus 2 is positive 1. And then when I solve this equation here, subtract 2, I get x equals negative 3 minus 2, which is negative 5. So I have two possibilities for my answer here. Positive 1 and negative 5. Okay, finally for number 7, I'm going to do the same thing as we did for number 6. So my first goal is to get this absolute value right here, the x plus 9, by itself. So I need to do two things. I need to get rid of this plus 3 first of all. So I'm going to subtract 3 from both sides. That's going to give me 2 times the absolute value of x plus 9 is equal to 4. And then I'm going to divide both sides by 2 to get rid of this 2 out here. Okay, and what that does is it gives me the absolute value of x plus 9 equals 2. Okay, what I'd like you to do from here is click pause and see if you can finish up this problem just like I did number 6, just like I did numbers 4 and 5. So go ahead and click pause, try to finish it up and get to your two answers, and then once you think you have those, click play to check your answers. Okay, let's check and see how you did. So from this step right here, you know that the absolute value of x plus 9 is equal to 2, so that means x plus 9 itself has to be equal to either 2 or negative 2. So these are the two equations you should have set up. Again, notice I dropped the absolute value bars from this point on. Once I write those two equations, you don't put the absolute values in anymore. You subtract 9 from the first equation. 2 minus 9 gives you a negative 7. On the second equation, negative 2 minus 9 gives you negative 11. So your two solutions to this equation are negative 7 and negative 11. Okay, we're going to do a lot of practice on this week, so be sure to write down any questions you have. Feel free to email me any of those questions before class if you'd like to. And until I see you again, have a nice day. You're all wonderful people. Take care.